Okay, so this section is on derivatives of logarithmic and exponential functions. All right, we already know that if we take the derivative of e to the x, then that is e to the x, right? Okay. We also know the derivative, or we don't know this yet. Now we will today. I'm going to tell you. All right, the derivative with respect to x of the natural log of x, okay, which is the base of that is e, right, is 1 over x. Okay, so again, those two you need to always remember because those come up a lot in other places and throughout calculus. All right. Now, if you have a different base, okay, so like if you take the derivative with respect of x of, like, say, b to the x, so some other base besides e, then you could actually derive the formula using this, but I will give this one to you. It is just going to be b to the x times the ln of b. Okay. And then if you have a log that is to a different base, so like say you're going to take the derivative of log base b of x, then really what you can do there is just rewrite log base b of x as ln of x divided by the ln of b. Okay? And then if you take the derivative of this, notice the ln of b is just a constant, right? It's just the ln of whatever the base is here. So if you're taking the derivative of a constant times something, you just bring the constant down. So you still have ln of b. What is the derivative of the ln of x? It is 1 over x. So if you replace that there, you get 1 over ln of b times x. And that's the derivative, okay? So 1 over x ln b would be the derivative of log base b of x. Okay? So those are the formulas for this section. Any questions about that? Okay. Let's do some derivatives here. All right, let's say that, so all these just say for now find the derivative. All right, let's say we've got y equals x squared ln x. Okay. Now, notice in the problem, I've got a product. I've got x squared times ln x. So to do the derivative, I've got to use the product rule. Okay. So y prime is equal to the first times derivative of the second. The derivative of the ln of x, we need to remember, is 1 over x plus the second times derivative of the first. So derivative of x squared is 2x. So that would be 2x times ln x. So that is product rule. Any questions about that? Now all I can do here really is just say x squared times 1 over x is x. I'm good with that. If my math lab wants you to factor it, then you could factor an x out and get that. But either one's fine with me. So, any questions about that one? Okay. Y equals the ln of x squared. All right. Now the 2, is the 2 squaring the ln of x or is it squaring x? It's just squaring x, okay? If you're going to square ln of x, you're going to have to put parentheses around that to do that, okay? So you can do one of two things. You can leave it like it is, and you would have to chain rule, right? So if it's ln of x squared, what is the big function if you're doing chain rule? Would the outside be ln or would it be the square? it'd be the ln would be the big outside one, because this is what you would have. So the x squared was like it'd be inside. You're taking the ln of the x squared, right? So you do the outside one first. So derivative of the ln is 1 over x. So I would say that's going to be 1 over x squared, because x is x squared in this problem. And then I got to multiply by the derivative of the inside function, which is the x squared. So the derivative of x squared is 2x. So I get 2 over x for the derivative. Okay? Questions about that? Now there's an easier way to do that one. Anybody know of an easier way you could do that? If you remember your logarithm rule, properties, all right? There's a property that says that if you've got the ln of x to a power, then that's the same thing as moving that power in the front. So ln of x squared is the same thing as 2 times ln x, right? Well, if I take the derivative of this, then I would just say 2 times 1 over x, and that gives me the 2 over x, okay? Either way works, okay? But questions about that? Now, one thing I didn't write up there is ln of x. This is true as long as x is greater than 0. Okay? So, if x is 0 or a negative, you can't take the log of a 0 or a negative number. Okay? So this is really only then. But if you have the derivative with respect of x to the ln of the absolute value of x, then that is equal to 1 over x for x, all x is where x is not equal to 0. Okay? So when you see absolute value, it's the same thing. It's just affects what x's would be in the domain there. Okay, so. All right, so derivative. All right, again, you've got an outside and an inside function. This one, I think it'd be easy to see the outside function is ln. Inside is sine. So first, take care of the outside part. Derivative of the ln is 1 over x. So in this case, 1 over sine x. Chain rule, multiply them now by the derivative of the inside. So times the derivative of sine. What is the derivative of sine? Cosine. Times cosine. So I've got cosine over sine. And we always want to try to write it with as few trig functions as possible. So what does cosine over sine equal? The other way. Close. Tangent is sine over cosine. Cotangent. Yeah. So cotangent x. All right. Questions about that one? Okay. So again, we've got ln here. So we remember the derivative of the ln is 1 over x, right? And this one you can do two ways as well. Let's go and do it the hard way first, which is probably how you would do it. So this would be 1 over x plus 1 over x minus 1. Okay? So 1 over that. Now times the derivative of the inside. The inside is a quotient. So you got to do quotient rule. Okay? So I would say the bottom times derivative of the top minus the top times derivative of the bottom over the bottom squared. Okay? And this actually reduces pretty well here. Notice on the bottom, if I take this fraction here and multiply it by this one, I've got x minus 1 squared over x minus 1, so this one cancels with one of those. So I would get x plus 1 times x minus 1. Then on the top, I would have x minus 1 minus x minus 1. So my x's would subtract off, so I end up with there negative 2 over x squared minus 1 for my derivative. Okay. What would be another way you could do that one? Along the same lines of this one that we did. Do you remember the log property where if you've got the log of a quotient, how you can break it down into multiple logs? Remember that? No? All right. Well, all right, here it is. All right, so what you could do is you could rewrite that as y equals the ln of x plus 1 minus the ln of x minus 1. So that would be expanding that log. That could go from here to here, would be condensing into 1. Okay. Now that's a lot easier to differentiate. You would have 1 over x plus 1 minus 1 over x minus 1. Okay. Now that is equivalent to this. Now if you went ahead and subtracted those, got a common denominator and subtracted, you would end up with the same thing. Now I don't know if my math lab would take this one or not. They might, but they might want you to add it together. Like I said, if you add it together, you just get a common denominator and put them together. So, all right, any questions? So, got your chain rule. Your outside function, of course, is that main ln, right? Inside function is ln of x. So do the outside one first. So the derivative of the ln is just 1 over x. So in this case, it would be 1 over this, 1 over the ln of x. Okay. So that's the outside one. Now, multiply by the derivative of the inside function. The inside function is ln x. The derivative is 1 over x. So multiply that times 1 over x. So the derivative would just be 1 over x ln x. Just like the last one, your outside function is ln, the inside is cosine squared x. So first I would have 1 over cosine squared x. That would be the derivative of that ln part. Okay. The chain rule, multiply by the derivative of the inside. So the inside part is cosine squared x. Okay. Well, cosine squared x is the same as this. So really, you still got two functions in there, right? So the outside of that function, outside function would be the power of 2. So I would say 2 times that, subtract 1 from the exponent. So I get 2 cosine x. But now I still got to multiply by the inside of that one. What is the inside? What is the derivative of cosine? Negative sine. So now I got to multiply by negative sine x. And that should be good there. Okay. But you got to follow the rules. Okay. So, any questions about that step there? You need to practice. Need to practice. All right. I've got 1 cosine here and 2 on the bottom. So that 1 can cancel with 1 on the bottom. So that would leave me with negative 2 sine x over cosine x. And again, if I can write it in with lower number of functions, trig functions, that'd be best. So what is sine over cosine? Sine over cosine. Tangent. So that would be negative 2 tangent x. So this is a quotient. Use quotient rule. So y prime equals the bottom times derivative of the top. So ln x plus 1 times derivative of the ln of x is 1 over x minus the top times derivative of the bottom, which is also 1 over x, over the bottom squared. Okay? Questions about that? All right, now what I would do there, I think, just notice on the top, you have a factor of 1 minus x in both terms. You got 1 minus x, you got 1 minus x, right? So you could factor that out. So if I factored that 1 minus x out, it would be the same as this. It would be the same as multiplying 1 over x times this. That would be the same thing. Does everybody follow that? Because if that 1 over x was just a 2, you just multiply the thing by 2, right, if you factor it out. If it's 1 over x and you factor it out, you just like multiplying it times 1 over x. Now that's a lot easier than multiplying the top and bottom by x and going through all of that. Well, I say it's really not. It's really the same thing. If you multiply the top and bottom by x, those will go away. You get x on the bottom. It's really the same thing. So, and now the ln of x minus ln of x, that goes away. So our final answer is 1 over x ln of x plus 1 squared. Okay? All right, so any questions about that? Now that is a product, right? So you got to do the product rule. So I have y prime equals, all right, the first times derivative of the second. Okay? The derivative of x to the e power. E is just a number like 2, right? So just do the power rule is all you do there. So I would say e times x to the e minus 1 power would be the derivative. Okay? Plus the second times derivative of the first, so I just get that again. That answer is fine with me. You could factor out an e to the x, and you could factor out an x to the e minus 1, because that's your small, e minus 1 is smaller exponent than e. So you would get e plus x, if you do e minus 1, you just get x to the first there. So that would be a factored form of the answer. Okay? Here's a few with powers. Exponentials where you don't have, where the base is not e. So let's say we have y equals 8 to the x power, and let's say we have y equals x cubed 3 to the x power. All right, so we have those. Follow the formula. Okay? Here's your formula. So that derivative would be 8x times ln 8. That's all you do. Okay? Questions about that one? And you'll get those formulas. You'll get these two here. You'll get on the test. Okay, you have to remember those. This is a product rule. First times derivative of the second. All right? 3 to the x, again, just use our formula there. So this will be times 3x ln 3 plus the second times the derivative of the first. So that'll be 3x squared times 3 to the x. Okay? And there, if you factored that, you have a 3 to the x in both terms, and you have an x squared that you can factor out. So I would say, let's factor out 3 to the x times x squared, and that would leave x ln 3 plus 3 for the derivative. Okay? All right, derivative. Okay, bottom times derivative of the top. So 2x plus 1 times, all right, the derivative of 2 to the x power, follow this formula, 2 to the x times the ln of 2, all right, so that's bottom times derivative of the top minus the top times derivative of the bottom, which is also going to be the same thing as this, because the 1 just gives me 0. So 2x ln 2. All right, any questions? I haven't done the bottom yet. So that's bottom times derivative of the top minus top times derivative of the bottom over the bottom squared. Okay. Questions about that? So a little reducing here. Let's see what we've got. We'll have 2x times 2x will be 2 to the 2x power. And then 1 times that will be 2x ln 2. Over here I would have minus 2 to the 2x ln 2 over I left off the ln 2 here, sorry. At the beginning it's 2x ln 2. Alright, and then the bottom is the same. So that's what you should get on the top there. And then you'll notice that this one and that one will subtract off. So I just have for the answer 2 to the x ln 2 over 2 to the x plus 1 squared. Any questions about that one? Calculate the derivative of the following functions. In some cases it is useful to use the logarithms to simplify the functions before computing the derivative. Okay, so these are just some that has a log with a different base besides e, so not a natural log. So let's say we've got y equals 4 log base 3 of x squared minus 1. Okay. Derivative. So I got 4 there times. All right, now log base 3 x squared minus 1. So notice you've got chain rule, right? So your outside function there would be what? The log 3, right? And then the inside would be x squared minus 1. So first do log 3. All right, well, I got to go over here to this formula. All right, so if b was 3, I just do this. So I have times 1 over x, which in this case, x is actually x squared minus 1, times the ln of b, b is 3. So that's the outside function, times the derivative of the inside, which is 2x. And now all you got to do is multiply that, and that's really all you can do. So that derivative would be 8x over, and however you want to write it there, that answer's fine. Okay, questions about that? Now, you could either leave it like that and do the quotient rule, or you could move it to the top and do the power rule. And on this one, I actually did that. I think one of the other ones before. So either way should work fine. For this one, I'm going to go ahead and just move it to the top and do it that way. So you can rewrite this like that. Okay? Now, if I rewrite it like that, you have chain rule again. What would be the big outside function on that one? What's the outside function on this? The power of negative 1, right? So I take care of that first. So I would have y prime equals negative 1 times that, and then subtract 1 from the exponent gives me a negative 2. Okay? That's the outside. Multiply by the derivative of the inside. Log base 4 of x. All right, well, that, and just follow that formula there. So times 1 over x times ln 4. All right. Now, I'm okay just to move that log base 4 to the bottom with the square on it. Okay, so you would do this. But when you do your homework in my math lab, they may not want it like that. I'm okay with that answer. Okay? But you can change it a little bit, all right? So if you remember the log base 4 of x, if you write that in terms of natural logs, this is the same as ln of x over the ln of 4. Okay? So change a base formula. This changes to that. So I could write this as ln of x over ln 4 is the same thing. Now notice I have ln of 4 squared on the bottom times the ln of 4 there. So this ln here would cancel with one of those on the bottom. So I would have this. I have that. And then to get where I don't have a fraction in the bottom, just multiply by the reciprocal. And that would change to be negative ln 4 over ln of x squared times x. That's how the book had the answer. Like I said, I'd be okay with this. But if my math lab does not want to take something in this form, that's what you would do to change it to where it's all natural log. So that looks like a mess, all right? So, but you can make this one easier because one of the things in the directions said, it said in there, in some cases it is useful to use the properties of logs to simplify the function before computing the derivative. So this is one where it'd be a lot easier to simplify it. Okay, so expand it. All right. So notice on the top you've got addition, you got your multiplying, and then you're dividing. So I could rewrite that as the ln of 2x minus 1 plus, and I could go ahead and move the 3 in the front and say 3 ln x plus 2, and then minus the ln of 1 minus 4x. So that is the same thing as this, using your properties of logs. Okay? That's easy to differentiate now, right? Because, so the derivative then would be, all right, this would be 1 over 2x minus 1, right? And then multiply by the derivative of the inside. The derivative of 2x minus 1, 2. So multiply times 2. And then plus 3 times, all right, the log of the derivative of the ln of x plus 2 is just 1 over x plus 2 times 1, right? And then minus 1 over 1 minus 4x times the derivative, which would be negative 4. I didn't write the problem down right. There's supposed to be a 2 right there. Exponent. Sorry, add that in. So that would put me a 2 right here, which would make that be a 2. All right. Now your answer. Good answer would be 2 over 2x minus 1 plus 3 over x plus 2 plus 8 over 1 minus 4x. All right, questions about that? Can we use this formula to do the derivative? No. Why can we not? What does b have to be? What do you think? It has to be a number. All right. If it's a variable, it would not. It's not a variable. B has to be a number. Base has to be a number. All right. Here, the base is a variable and the exponent is a variable. Okay. So we can't use that to differentiate this. Okay. But we do have something called that was called is called a logarithmic differentiation that we do. Okay. And the main thing that you need to remember when you use logarithmic differentiation, it is going to be when you've got a variable raised to a power that has a variable in it. That is when you will want to use this. And it does come up from time to time later on. Probably in some problems in Cal 2, it probably will come up some. So you will see it again. Now, the book, this textbook, it may show a different way of doing it. Okay, so I think on the homework, you're going to get something like this. I think it's going to say, find the derivative of x to the 10x power. Okay. First, write it like this. Or write it as y equals x 10x. Okay, so I think whenever we have the test and I put the review in there and I make the test, if you want to do the retake in there, I'm going to change the way the problem looks. I can go in and edit it, but I didn't have time before I did the homework for this. So in the homework, you're going to see this, but do it like this. Okay, so if they give you this, write y equals x to the 10x power. Okay? Now, this is what we do. It's called logarithmic differentiation because you use logs to help do the derivative. All right? Take the ln of both sides. So, if those are equal, then that means the ln of y should equal the ln of x to the 10x. So do that. Okay? All right, now take the derivative of both sides. Okay? Now, be careful. All right, on the left, you've got log, they got the ln of y. What is the derivative of an ln? 1 over, in this case, y, right? Times the derivative of the inside, which is y prime. So 1 over y times y prime is y prime over y. So the derivative of y is y prime over y. Any questions about that? Equals. Now, here, okay, before I do that, let me erase that real quick. All right. By taking the ln of both sides, what that allows you to do is take this exponent and get it off of that x by that property. So now I'm going to rewrite it like this. And then now I can take the derivative of the right side. Okay, so I got ahead of myself. Okay. Now ln y, again, that's y prime over y. Okay, on the right side now, do the product rule. So I would say the first times derivative of the second plus the second times derivative of the first. Okay. So product rule on the right. So now I would have y prime over y equals 10 plus 10 ln x. Okay. Now, to solve for y prime, what I do to both sides now to solve for y prime? I want to get rid of y. Y prime divided by y, what's the opposite of divide? Multiply. So multiply both sides by y. And I will get y prime equals 10 plus 10 ln x times y. Okay? Any questions up to that point? Now, I don't want to leave y in the answer like that. So all I got to do now is just say, well, what is y? Well, y is x to the 10x power. Right? So put that back in there. Y prime then is equal to 10 plus 10 ln x times x to the 10x power. Okay? Of x to the ln of x power. Okay? So you've got the base is a variable, and you got a variable in the exponent. So that tells you I'm going to have to do logarithmic differentiation in order to find the derivative. Okay? So first thing, set y equals to that. Okay? Then take the ln of both sides. Okay. Now by taking the ln of both sides, I'm able to get that exponent off of the x. So this then is equal to ln of x times ln of x. So this would just go down in the front. Now I have that, I definitely can take the derivative of both sides of that. Okay. Questions? Derivative of ln of y, just like the last problem, is y prime over y. Okay, ln x times ln x, you could either square it, write it squared and do the derivative, or either do the product rule. I'm just going to do the product rule. So first times derivative of the second plus the second times derivative of the first. So this is equal to 2 ln x over x. Okay. Questions about that so far? Now, I don't want to forget about my y on the left, right? Correct? So I got y prime divided by y. So to get y prime by itself, multiply both sides by y. So that will give me y prime equals 2 ln x over x times y. Okay. No reason to leave y in the answer, because I know that y is equal to, y is explicit. It is x to the ln of x power. So I need to write my final answer then. Y prime equals 2 ln of x over x times x to the ln of x power. So let's put it like this. That would be my derivative. So again, notice you've got your base is a function of x and your exponent is a function of x. So the only way to do the differentiation, logarithmic differentiation. So first thing, I'm going to set that equal to y. Okay. And I'm going to take the ln of both sides. Okay. Again, by taking the ln of the right side, that enables me to get that tangent x off of that exponent. So now I can rewrite the right side as tangent x times the ln of the sine of x. Okay? All right, any questions so far? Take the derivative of both sides with respect to x. So on the left side, again, I get y prime over y. Okay. On the right side, I have a product. So I've got to do the product rule. So I would say the first, tangent x, times derivative of the second. So on the second one there, I've got a function inside a function. The outside function is ln. The inside function is sine x. The derivative of the ln would be 1 over sine x. Now, times the derivative of the inside function, the derivative of sine would be cosine. Okay? So that is the first times derivative of the second, plus the second times derivative of the first. So ln sine x. All right, what is the derivative of tangent? Secant squared. Okay? All right, notice this first one here. What is tangent equal to? What over what? Sine over cosine. So sine on top, cosine on the bottom. So if sine is on the top, it'll cancel with that sine. Cosine on the bottom will cancel with that cosine. So this whole thing here just turns into 1. So that'll be 1. So again, don't forget your y over there. So 1 plus, and then that one I can't do anything with. So I'm going to write, let me write secant squared x ln sine x. Okay? Now, I got to do something with that y, so let's multiply both sides by y. So y prime is equal to 1 plus, I tell you what, let me go ahead and multiply it here. Have that times y, okay, and again, y is given explicitly here, so let's just put that back in. Y is sine x to the tangent x power. So my final answer then for my derivative is 1 plus secant squared x times the ln of sine x times y, which is sine x to the tangent x power. That would be my derivative. Okay? F of x equals x to the 10th power. Okay, so I definitely have a base that's a variable, exponent that's a variable. So quickly, we'll write it with y, and then I'm going to take the ln of both sides. Which will then enable me to write the right side as x to the 10th power times ln x. Okay? Take the derivative of both sides. So the left side will be y prime over y. The right side is a product. So I'm going to say the first x to the 10th times derivative of the second plus the second times derivative of the first. Okay? And that simplifies pretty easy to x to the 9th plus 10 x to the 9th ln x. And then multiply both sides by your y. And y is equal to x to the 10th power. So the derivative is x to the 9th. And I didn't factor it, I just left it like that. X to the 10th power. There you go. All right, questions about that? All right, that's all of 3-9.